Now let us see about the example number 3. The example number 3 says that now we have 10 sources, 6 with a bit rate of 200 kbps and 4 with a bit rate of 400 kbps to be combined together. And that will be using the multi-level TDM with the no synchronization bits added. Answer the following questions about the final stage of the multiplexing. So as a part of the revision of the multiplexing, if you have forgotten already about what is a multi-level multiplexing, so there is a refresher. The multi-level multiplexing, we combine several sources into one, what you can say, into a combined, or if we have larger multiplex table and a larger multiplex section where we can have a similar number of the channels to be transmitting over the multiplexers, because that in that cases we don't have to think about the different kinds, we don't have to think about the handling different kinds of the input channels. We can combine them in to make them even or equal among them all together. So basically the idea of the multi-level multiplexing is that you are going to combine several sources into one to make them of unique or same exact times of the input channel. So now they are saying that if we have the 10 sources, now we could have in the initial we have the 10 sources, 6 of them with the 200 kbps and 4 with them with the 400 kbps. Now in case of the, you would be tempted that okay, I would break those 400 kbps with the 400 kbps into some 8 200 kbps. That would be possible, but they are saying that you have to use the multi-level TDM, that meaning that you have to combine the lower one into the more into the greater ones. Okay, so the lower channels will be, now they will be combined into the greater in channels. So now how can we do? We can make those 6 channels into a 3 400 kbps. So the idea is that this is my 1, 2, 3, 4, 5, 6. Okay. So what we can make, and then let us take this example. Now let us take this 1, 2, 3, 4. All the green black ones are my 200 kbps. Okay. The black ones are 200 kbps, 200 kbps, 200, 200, 200, and this is my 200, right? And the blue ones, those things are my 400, 400, 400, and then 400. Okay. So now we know that for the multi-level multiplexer, we have to combine the lower input channels into some greater input channels, into higher input channels. So we can combine these two. So making them, if we can combine these two, this will be my 200 plus 200, 400 kbps. And if I combine these two, this will be my 400 by 400, 200 plus 200 is 400 kbps. Okay, so combine these two, then we can combine these two to make them as a 400 kbps. So now how many 400 kbps we have? We have the 1, 2, 3, 4, 5, 6, 7. So now we have 7, 400. We have the 7, write it, 7 400 kbps channels. Okay. So now we're not going to talk about the 6 200 and the 400. Now we're talking about the, now we have, instead of all these things, now we can say that now we have 7, not the 10. Now we don't have the 7. We have directly, now we have the 7 400 kbps input lines. Okay, input links or input channels, whatever you might prefer to call it. Okay. Now let us do this math. What is the size of the frame in, what is the size of frame in bits? Now we know that we don't have any kind of synchronization bits, so we are safe on that. Okay. Each of the frames, now we know that each of the frames, so in normal cases, we will be multiplexing 1 bit from each of the channel, we'll be multiplexing only one bit from each of these channels. So to question number 8, I'm not just going to be deleting those parts because that's not necessary now. Okay, let us keep it here. So the question number 8. For the question number, what is my size of the frames in the bits? Size of a frame in bits. Okay, how many frames? The size of the frame? 7 channels. Now we have the 7 channels, and all the 7 channels, and let's say now we're going to multiplex one unit each of the time. So the frame size, the output frame size will be 7. There will be 7 channels. Okay, there will be there will be several channels. There will be 7 channels, so there will be 7 slots. 1 2 3 4 1 2 3 4 5 6 7 1 2 3 4 5 6 7, and there will be 1 bit. So this is my 1 bit, this is my 1 bit, this is my 1 bit, 1 bit, 1 bit, 1 bit, and 1 bit. So there will be total 7 bits. Okay, so the output frame size is 7 bits. And for the question number 2, what is the frame rate? Okay, what is my frame rate? Now we know that we have two we have two formulas from that: output frame rate, one for the multiplexing unit and another with the frame duration. We don't know the frame duration yet, so going for the first formula. The output frame rate is equal to the input rate. Input rate is 400 kbps, and then we are taking 1 bits from each of the channels. The multiplexing unit is now 1 bit, so there will be 400 kfps, 400 kiloframes per second. What is the duration of a frame? Question number C, basically the reverse of that, 400 kfps. I think that is going to be my 400. So 40. Okay, no, that is not going to be the 40. That's going to be 2.5 microseconds. And what is my data rate? The data rate now could be, so now we don't have any kind of synchronization bit. So we can use this formula, we could use that formula too. So whatever the preferable call is that. So we know that in the modified version, now we have 7 channels. In the modified one, because we have combined, we are multiplexed the 200 into the 200 into the 1 400. So n is equal to the 7 number of the channels. Now we have the 7, and my input bit rate, the input bit rate is 400 kbps, right? Input bit rate is basically the 400 kbps. So what we can do, we can simply make the output frame rate, output data rate, output bit rate or output data rate, those are the same thing. So output data rate, we can use this formula, and we can also use this formula. So basically those are giving the same formula, okay, the same answer. So the 7 into 400 kbps, so this is going to be 200 and 2800 kbps, 2800 kbps or 2.8 mbps. 2.8 mbps. So this was using the first formula. Now if we will also do the second formula, or we can use the second formula. In the second formula, there's the frame rate into the frame size. So my frame rate into the frame size. So what is my frame rate? My frame rate was 400 kfps. And what is my frame size? My frame size was 7. Okay, 7 bits. So basically, those are also the 280 kbps, and that is going to give you the 2.8 mbps. So basically, those things are giving you the same result. And that's how you use the multi-level multiplexing. They will be giving you some kind of hint whether you're going to use the multi-level multiplexing or you are going to use the multi-sort multiplexing. Remember, in the multi-level multiplexing, we are combining the levels. We're making the lower ones into some higher ones. And in case of the multi-slot multiplexing, we are doing the reverse. We are just splitting the higher ones into several smaller ones. Okay, so that was the part for the third math number 3. Let's look forward to this another one.